Hello everybody, welcome to your first Chem Talk for Unit 2. So you should have your green sheet out and open to the very first page. So hit the continue button when you have your green sheet out and ready and a pencil to take your notes. And I'm going to get started. So we're going to start with physical properties. There we go. Physical properties are properties that can be observed or measured without changing the chemical makeup of your material. Oh boy. There we go. So some examples of physical properties would be color, density, odor, mass, and volume. So we can observe the color or the smell of something without changing it. We're not going to have an entirely new substance after observing these. Same thing with mass, volume, and density. We can measure those, and we have measured those in class, and it did not damage or change the identity of our substance. All right, next we have chemical properties. And these are properties that relate to the likelihood of a substance to transform into a new substance. So if we are testing a chemical property, you are likely to end up with an entirely new substance afterwards. Right, so some examples would be reactivity, right? Maybe your substance is participating in a chemical reaction, combustion, so we are burning it, or flammability, testing if it can burn. So usually after performing any of these tests, we now have a completely new substance. So let's say we're burning something like magnesium. After we burn it, we now have magnesium oxide. Or we're burning a log of wood, and afterwards, when you go to find your log of wood, you might notice it's not there. And we now have a pile of ash, as well as all the smoke that was created. Okay, so when we're thinking about these two, we want to think physical properties are properties we can test without changing the identity of our substance, and chemical properties are properties that we can test that would change the identity of your substance. All right, so let's determine if the following are chemical or physical properties. Take a second on your paper. I want you to write down a C for whether it's a chemical property and a P for it being a physical property, and then we'll check our work with the Ed puzzle. Very good. Alrighty, so moving on to physical and chemical changes, right? These are different than properties. So properties are characteristics or attributes of a substance. Now these are going to be us making a change or altering our substances. So here are some examples of physical changes. We have stuff like boiling, cutting, freezing, breaking, dissolving. These are all things that we can test without changing the chemical makeup of our material. So it would be the same before and after. So imagine boiling water. Right? So we start with liquid water in our beaker. We boil it on a hot plate. It now turns into gaseous water. Right. The chemical makeup of our material is still H2O. It has only changed its phase, so we know that it is a physical change. Right. And something you might hear me say quite a bit is that a phase change is a physical change. So anytime we are going from one phase of matter to another phase of matter, but the substance is still staying itself, then we have a physical change. Same thing with cutting or breaking something, right? You drop a beaker in the chemistry lab, right? And while that's unfortunate, right, it's still made of the same Pyrex glass mixture that we have. It's not changing its identity, it's just breaking into smaller pieces. Another example is dissolving. So if we dissolve salt or sugar into water, we're not actually changing the identity or the chemical makeup of our salt or sugar that was being dissolved. It's just being separated into much smaller pieces and spreading out throughout the solvent or our water. Alrighty. So that is physical change. Remember, this is not changing the chemical makeup. All right. And we already talked about some of these examples, so make sure you have those written in. Alright, so we're going to talk a little bit more about dissolving. So when one thing is dissolved in another thing, we call this substance a solution. All right, and this should sound familiar to you. I think we talked about this with our mixtures unit. So a solution consists of two parts, and again, this should not be new to you. We have a solute, that is a substance that is being dissolved. So in this case, it could be salt or sugar being dissolved. and our solvent is what is doing the dissolving. So most likely that is going to be water or a liquid. The more solute that you dissolve, the higher the concentration of your solution. And so imagine making some Kool-Aid, right? The more Kool-Aid powder that you dissolve into your water, the sweeter and the stronger the taste of that Kool-Aid is going to be. While in reverse, if you only put a little bit of Kool-Aid powder in there, it's not going to taste as sweet as it would. So the more solute, or the more of the solid that you put in there to dissolve, the higher the concentration. So we will be talking about 3 different types of solutions in this unit. All right, the first one is a saturated solution. And this is a solution that can't dissolve any more solute. Right? A great example of this would be to think of a sponge. So typically you might see like the big square yellow sponges that we have in Chem Lab, and it can absorb water. But eventually, once that sponge absorbs enough water, right, it's actually not going to absorb any more, and it will just let water flow through it. So that's what we're going to think of something as saturated. Once it has filled up as much as it can, right, or dissolved as much as it can, then it is saturated. Now, if a solution can still dissolve more of a solute, right? So think about when we have a dry sponge and we're just beginning to start to soak it up. So that would be something that is unsaturated, and we still can dissolve more of our solute into it to increase the concentration. Now there is a third one, and we call this supersaturated. And it's probably just what you think. So this is a solution that we have dissolved more solute than would typically be allowed under normal conditions. And the way we can do that is by heating up our solvent or our liquid as we are dissolving our solute into it. Maybe you've had that southern style sweet tea from Mission Barbecue, or maybe you have a family member that makes really good sweet tea. The reason that they can make it nice and sweet is because they dissolve the sugar into the tea when it is very, very hot, instead of making iced tea, right, and dissolving it when it is cold. So we can get a much stronger, sweeter tea, right, if we dissolve all that sugar while it is heated up. Now we have an example here I'm about to show you. So this is an example of a supersaturated solution. So as we take a look here, right now we have sodium acetate. They had heated up when they dissolved our solute into the solvent, and now you're going to see the scientist is going to drop a little probe or a metal piece into there, and that little agitation of our solution is going to cause the solute that was dissolved in there to crystallize. You get a really nice, cool effect here, as because we have more of our solute dissolved in there than we typically should. Right? Once we have a little bit of agitation, it all goes back to being a solid again instead of being dissolved. So that is a good video example of a supersaturated solution. Alrighty, let's talk about chemical changes now. So this is when we transform from one substance into a completely new substance. Right? So imagine heating up some sugar on the stovetop. Right? It has a white granulated substance. Right? When we heat it up, it turns into like a very high viscosity brown liquid. Right? Sometimes we call that caramel, or maybe even molasses. I'm not really sure what molasses is. But it definitely has a different, right, set of properties than the original sugar. Now, once we stop heating it up and let it cool down, right, we're left with this charred black mess. So because we have a completely new substance at the end than we had at the beginning, we underwent a chemical change, right? Our substance has transformed into something new. So before heating, during heating, and after heating. All right, so chemical changes. The new substance is formed in a chemical change, has entirely different properties and reactants, or than the reactant. So we would have, if we're looking back here, the white crystal type substance here, and then we have a black charred mess, right? Completely different. And so making salt is another great example. So we're putting together sodium which by itself is a very reactive metal. Just putting a piece of sodium in water causes an explosion. Right, so eating pure sodium probably would not be a good idea. Your jaw would probably explode. We're combining that with chlorine, which is a dangerous gas that has been used throughout history to possibly poison people. Very, very dangerous chemical to mess with, chlorine gas. But we combine these two, and we end up with table salt, right? Something that you have on almost all of your meals. Right? It's not magic. This is science, right? And we underwent a chemical change because we went from having two very dangerous substances with some frightening properties to a very stable and safe compound. So because we have new properties, we underwent a chemical change. I would definitely put a star next to your signs of a chemical change here. All right, this is hugely important, and you must know these. So number one, if you notice a change in color, most of the time this is a sign of a chemical change. So we put two substances together, and a whole new color is created. Or you might think of burning that sugar that we talked about not too long ago. It has gone from that white color to a black color. Bubbling. When you see bubbling, when combining two substances, a gas is being produced. Now, this does not include when I heat up a substance and bring it to a boil. Because remember we said a phase change is a physical change. So boiling is not included here. Think of the typical reaction of adding baking soda and vinegar. As those two things come together, right, it starts to bubble up on their own, and that's because a gas is being produced as one of the products in this reaction. Right, so if we see bubbling taking place, but we have not heated up our substance, that was a chemical change. Formation of a precipitate, and I have a nice video to show you in a little bit of what a precipitate is, but it's basically just a solid that is produced when you mix two liquid solutions together. Right, so if we take a look here, right, we're going to add our two liquid solutions together. And as we do, you see this yellow solid being formed. This is what we call a precipitate. So the scientist is going to just mix it around here. Now, if we let it sit out over time, all of that solid should fall to the bottom. And that's kind of why we call it a precipitate. Because I'm sure you're familiar with the term precipitation is when water in the form of liquid or solid falls from the sky. So you see that we have our solid that was produced all fall to the bottom. This is our precipitate. Okay, you definitely need to understand and know that. And our last sign of a chemical change is a change in temperature. So if we put two things together and the temperature increases or decreases, we know we have a chemical change. It's because either energy was produced or used for that reaction. Now again, this does not include us heating something up. The change is going to occur only because of the reaction, not because of any energy that we, the scientists, are adding to the reaction. All right, so let's take a look at some of these examples here. I want you to tell me whether or not these are chemical or physical changes. So water heated in a microwave, is that a chemical or a physical change? Water freezes into ice, an iron nail rusts, a gas is compressed with a pump, a silver coin tarnishes, a lump of coal burns, table salt is dissolved in water. Right, so I want you to answer whether these are chemical or physical changes. All right, so that is the end of our PowerPoint. What I want you to do to finish out the rest of your chemistry for the day is you need to complete the Chem to Go and your green sheet. So it looks like a lot, but it really is not too much. You're going to finish out the bottom of page 2, and then I also want you to complete pages 3 and pages 4, identifying a chemical or physical change in your Chem to Go green sheet. So pages 1 through 4 should already be completed by the end of the day. Alrighty, I will see you soon. Goodbye.